Hi, welcome to your lesson on scientific notation. This is a very big idea. We use scientific notation all the time in science and then consequently in mathematics. Let's take a look and make sure you know this important system. Let's begin here. If you were to estimate the height of this house in meters, what would you say? I'm not quite sure, but I estimated about 2 meters per floor, making that a 4-meter house with 2 floors there. Maybe you came up with a number similar to that. Now, if somebody said that same house, instead of giving us an estimate in meters, how about giving us an estimate in centimeters? What would that be? And let's use the 4 meters I began with. Well, we know for every meter there are 100 centimeters, so that would be 400 centimeters. Okay, so notice kind of a simple number became a longer number, and that often happens when we change the unit of measure. But 400 is still a reasonable number. However, what if we were asked to give the circumference of the sun in centimeters? Well, you might not know this number, so let me show it to you. There is the circumference of the sun. We are in the billions here. That number is not too long, but it's starting to get long enough where it's a little inconvenient to write it, and it might be tough to use that number in calculations. And that is precisely why scientific notation was invented. It's to allow us to write really big numbers like that in a different way. Well, first of all, this is not scientific notation, but I can convert that to kilometers, and now it's a little more reasonable. It's shorter. Kilometers are definitely a better unit of measure to use here. However, in scientific notation, it would look like this, which is even more convenient. We always write it like this. You can see 4 points. We always write a number here that's less than 10, so a number from 1 to 10, and then decimal to represent the other digits here. And then we always multiply by 10 to some power. And the way we obtain that power is by counting how many decimals, how many times the decimal would move to get to there, right? If we began with the decimal here, we can count that we would move back 11 spots to get to here, and that's why we have 10 to the 11th power. That is scientific notation. So, what is standard or scientific notation? It is a way of expressing really big numbers or really small numbers. So again, really big numbers, another example is the circumference of planet Earth, which is this in centimeters, but it is this then in scientific notation, a little easier to work with. And a really small number, well, the circumference of an atom. And we can see that's a really small number. And that can also be expressed in scientific notation. And now we see, instead of a positive exponent, we see a negative. Because a negative exponent tells us we are dividing by 10 to some power rather than multiplying. When you divide by 10 to some power, you're going to make your number get smaller, smaller, smaller. Okay, so it is most often used in scientific calculations where analysis must be very precise. Here's some more examples. With scientific notation, Avogadro's constant, which is the number of particles, atoms or molecules contained in 1 mole of a substance, is written as this. So notice we have 6 point and then a bunch of decimal places, but it's times 10 to the 23rd. If this was not written in scientific notation, it would take 24 digits to write it, because those 23 here means that that decimal will move 23 spots. Yeah, I don't think I wrote that one, but anyway, imagine that decimal moving 23 spots, quite long. Here's some other things. The number of internet users in the world up to June 2010 was this, 2 times 10 to the 9th. So that's in scientific notation. If that was written out in full, it would be like that. Not so bad, but again, this is easier to work with. The mass of Earth is about 5.97 times 10 to the 24 kilograms. That one, if it was written in full, would look like this. Okay, that 24 means that decimal moved 24 spots to the right, and we end up with all these zeros. That's definitely inconvenient to write or work with, so this scientific notation is great for that. Another example, an estimate of the average mass of a human cell is about 10 to the negative 9. That would be written like this, if not for scientific notation. Again, we see the negative here, telling us the number will become small, and that makes sense for the mass of a human cell. So scientific notation makes these numbers more convenient. Here are some rules. Here's the first rule, and you'll often see this kind of exactly this written on IB exam questions. It says give your answer, or a number written in standard form is written like this: a times 10 to the k, where a is between 1 and 10, that's what this means, and k is an integer. So let's break that down. It's exactly what we've seen. A must be between 1 and 10. We talked about that. See, A is between 1 and 10. It's greater than 1, less than 10. So A must be some number between 1 and 10. And then K must be an integer. That means the power you put on 10 must be a whole number, positive or negative. It cannot be like to the power 8.6. It's always power 8, or power 10, or power 20, or power -9. So that must be an integer value. Okay, so a lot of words there, but that's all it means. So these numbers are written in scientific notation. They follow the rule. Look, 2 is a number between 1 and 10 times 10 to an integer power. And here we have also a number between 1 and 10 here. This whole number is between 1 and 10, even though there's decimal value, so 5.97, and the exponent is an integer. And here we don't see anything, but this is okay for scientific notation, because this just means 1 times 10 to this value. Okay, so which of the below are written in standard form or scientific notation, and justify your choice. Okay, there I hope you chose. The first one is, the second one is not, because this is not a number between 1 and 10. The third one is not, because this exponent is not an integer or whole number. This one is not, because we don't see it multiplied by 10 to some power. And this one again is not, because this is not a number from 1 to 10. This number is less than 1. So if you had that decimal over one place and change this as a result, it would be. Okay, let's talk about where the word or the name of the company Google comes from. Google is a misspelling of the word Google, like that, which represents this number. It is actually, I think, 10 times 10 to the 100th power, I believe. So this giant number was kind of created, I think, in the 1950s, and then misspelled as Google, like this. Google is a number 1 followed by 100 zeros, and the name Google was invented by a 9-year-old who was asked by his uncle, to the American mathematician Edward Kasner, to think of a name of a very large number. So this 9-year-old said Google, okay, and that became the word for that number. In standard notation, we would have 1 times 10 to the 100. Okay, on your calculator, the calculator uses a different kind of notation for scientific notation. It is called e-notation. Let's take a look. Okay, here I have my calculator. I entered this multiplication. Do it on yours and tell me what answer is shown on your calculator. On mine, it shows me this. I hope you saw the same thing. So we have 8.62 and then some more decimals and then E10. All that means is this times 10 to the power 10. When you see E10 here, it means 10 to the power and whatever number you see here. So coincidentally, this is also a 10. But know that if this was an 8, for example, this would mean times 10 to the power 8. So this is scientific notation on your calculator. Okay? We'll use that later a little bit more. Okay, so now convert these to standard form or scientific notation. And all you have to do is imagine the decimal starts here and then slide the decimal back to here and count how many jumps that was. And now I'll tell you what power you put on 10. So what's the answer for this one? Well, this one is 2.898 times 10 to the 8, because the decimal moved back 8 spots. Okay, next one. Try this one here. Oh, sorry. On the calculator, that would be shown as this. Again, remember when we have times 10 to some power, it's going to show E8. That means 10 times 10 to the power 8. Okay, next one. Try this one. Okay, I hope you came up with this, and I hope you remembered the -4 here, because remember when we are showing a small number, we're going to have a negative power. So this moves back 1, 2, 3, 4 spots, so 10 to the -4. On the calculator, that would be this. Okay, E means times 10 to the -4. All right, a couple more. These ones now you're going to reverse. We have it in scientific notation or standard form, and we're going to expand. So what would be this full number here? That would be this. All you do is move the decimal 6 places. How about this one? Okay, again, you saw the negative, So the decimal was not moving right, it was moving left, making this a smaller number because it's the same as dividing by 10 to the 7. That's what this negative means. It means like it's dividing by this. And we get this value here. All right, now we're going to take a little diversion into the laws of exponents, because often when we work with scientific notation, since it's given in exponential form here, we need to know how to work with exponents. So here's a reminder of the laws of exponents. Anything to the first power is itself, right? Here's a numerical example. 6 to the first power is 6. Next one, anything to the 0 power is 1. So for example, 7 to the 0 power is 1. Here's the thing we were just talking about, negatives. When you have a negative exponent, it's the same as 1 over that thing. Here's a numerical example. 4 to the negative 1 is actually 1 over 4. If this said negative 2, it would be 1 over 4 squared. Okay, that's what we're doing with scientific notation when we have the negative values. Okay, another important rule. When you're multiplying two exponential things and they have the same base, then all you do is add the exponents. Numerically, if you had x squared times x cubed, you just add the exponents and you get x to the 5th. I hope you're writing these down. If you haven't yet, pause and write these down. Now I'm going to show you one more slide of rules. Okay, moving on. When you have two exponential things that are with the same base and you're dividing, the rule is you subtract the exponents. So for example, x to the 6th over divided by x squared, you subtract those exponents, you get x to the 4th. Next one, when you have parentheses around one exponential expression and you have an exponent on the outside, you multiply the two exponents. For example, x squared to the 3rd power, you would multiply the 2 and 3 to get x to the 6th. And here we have the same thing, but two things on the inside, so the exponent on the outside applies to both parts. Let's take a look at this one. We have x times y, and there's a 3 out there. Well, that 3 will cube the x and the y to get this result. All right, so if you have a division of terms, that rule will work the same way. If an exponent out here, the exponent will go on the x and the y, like this. For example, x over y squared, that 2 will go on the x and on the y, like this. Finally, here's the rule about the negatives one more time. If you have x to the negative power, it ends up being 1 over x to the n. For example, x to the negative 3rd power is 1 over x cubed. And that is the same as when we had 10 to the negative power in scientific notation. I was telling you it's the same as dividing by 10 to that power. All right. Okay, so I hope you wrote down those rules because I want you to try these now using those rules. Try all of these, simplify them based on the rules we just learned. What will they be? And let's check our work here. First rule here, you multiply those when you have the parentheses, so x to the 6th. This rule here, that 4 goes on the 1 and the x, but 1 to the 4th is just 1. And then when you put that 4 on that one here, you have x to the 8th. But when you have an x to the 8th in the denominator, it can jump up and become x to the negative 8th, like this. Or in this case, they moved x squared up first, made it negative, because whenever you move it up or down, you change the sign, and then that 4 multiplied that, became that. C, you know, when you have parentheses, you just multiply the exponents. So that times that would be negative 3, and therefore you can write it down here like that. So here's the answer, negative 3. And finally, when you have division, you just subtract the 2. In this case, the mistake students often make is 5 minus 2, but you always do the top exponent minus the bottom. So 2 minus 5 is negative 3. Okay, now give these two a try. And check your work here carefully. Make sure you're able to get to those answers. Let's do one more. The last one is this. You are to find the volume. To find the volume of something, you may remember you do length times width times height when it has a cuboid shape or like a rectangular prism. So try that. Okay, so maybe you are able to try on your calculator, but also you should know how to work this on scientific notation. So you take the numbers in the front, you multiply them, you get a result, and then you combine all the 10 to whatever power like this. Using rules of exponents, all those exponents will just add up like this, and that gives you this exponent. Now, on your calculator, it's important to know how to do that. Oh, the final answer is this. On your calculator, you can punch in E notation rather than doing times 10 to the whatever power. So I did 2.44, and then second comma, because there's that EE, that's E notation. and then -6 for this one. I did negative here and then 6. Try that with all three and see if you get the same answers we have here. It's important you know how to use that notation. You can do it.